This set of slides looks at the quality of mean variance inputs. So we know that mean variance allocations are highly sensitive to small changes in inputs and therefore estimation error. Estimation error in expected returns is estimated to be roughly 10 times as important as estimation error in variances, and 20 times as important as estimation error in covariances. Best and Gura demonstrate that a small increase in the expected return of one of the portfolio's assets can force half of the assets from the portfolio. Thus, the most important inputs in mean variance optimization are the expected returns. But these are hard to estimate as well. So because we have little confidence in a single mean variance optimization, professional investors often rerun an optimization many times using a range of inputs to gauge the result's sensitivity to variation in the inputs. An alternative is Michaud's resampled efficient frontier method. So the resampled efficient frontier uses a data set of historical returns to generate simulated returns. Historical means, variances, and covariances are assumed to be true population parameters. It produces a set of simulated efficient portfolios and ranks by return for each simulation trial. Resampled efficient portfolios for a given return rank has weights that are the average weights from those simulated efficient portfolios with that return rank. The advantages of the resampled efficient frontier is that the portfolios resulting from the resampled efficient frontier approach tend to be more diversified and more stable through time than those in a conventional mean variance efficient frontier developed from a single optimization. The challenge is that the resampled efficient frontier approach has been questioned because of the lack of a theoretical underpinning for the method and the relevance of historical return frequency data to current asset market values and equilibrium. Another alternative is the Black-Litterman approach. The unconstrained Black-Litterman model, otherwise known as UBL, it takes the weights of asset classes in a global benchmark such as the MSCI World as a neutral starting point. The asset weights are adjusted to reflect the investor's views on expected returns of asset classes according to a Bayesian procedure that considers the strength of the investor's beliefs. The UBL model is a direct method for selecting an asset allocation. It usually results in a small or moderate deviations from the asset class weights in the benchmark in intuitive ways reflecting the investor's different from benchmark expectations. Because the UBL model is anchored to a well-diversified global portfolio, it ensures that the strategic asset allocation recommendation is well diversified. This model allows investors to formally recognize constraints in optimization and is thus more important in practice. The Black-Litterman model, the BL model, uses an approach that reverse engineers the expected returns implicit in a diversified market portfolio, which is a process known as reverse optimization. And it combines them with the investor's own views on expected returns in a systematic way that takes into account the investor's confidence in his or her own views. These view-adjusted expected return forecasts are then used in an MVO, mean variance optimization, with a constraint against short sales and possibly other constraints. The BL model is popular with practitioners because of the ability to impose its own views on some assets' expected returns. It can be a tool for developing capital market expectations for the range of asset classes in a global index such as the MSCI World. It may also be viewed as an asset allocation process with two desirable qualities. The first one is that the resulting asset allocation is well diversified, and secondly that the resulting asset allocation incorporates the investor's views on asset class returns, if any, as well as the strength of those views. The BL model assumes that the historical asset class variances and covariances are correct. The estimation process can be thought of as a back-solving of the mean variance optimization to find the expected returns that would make the portfolio represented by the capital market weights mean variance efficient. These are the equilibrium returns that the model uses those returns as a neutral starting point. It can incorporate views and confidence in views about a subset of assets, and then you run the MVO. This is a table that describes the steps to the BL model. So firstly, you define the equilibrium market weights and the covariance matrix for all asset classes. And we do that because we need the inputs for calculating the equilibrium expected returns. Secondly, we backsolve the equilibrium expected returns in order to form the neutral starting point for formulating expected returns. Thirdly, we express the views and confidence for each view, and this allows us to reflect the investor's expectations for various asset classes. The confidence level assigned to each view determines the weight placed on it. The fourth step is to calculate the view-adjusted market equilibrium returns, and we form the expected return that reflects both market equilibrium and views. And lastly, we run the mean variance optimization to obtain the efficient frontier and portfolios. So a practical goal of the BL model is to create stable, mean variance efficient portfolios which overcome the problem of expected return sensitivity. A major advantage of that approach is that its starting point is a diversified portfolio with market capitalization portfolio weights, which is optimal for an uniformed investor using mean variance approach. Combining the investor's views with equilibrium returns helps dampen the effect of any extreme views the investor holds that could otherwise dominate the optimization. The equilibrium returns are the set of returns that makes the efficient frontier pass through the market weight portfolio, and they can be interpreted as the long-run returns provided by the capital markets. They represent the information that is built into capital market prices and thus reflects the average investor's expectations.